Alright, in this lesson we're going to transform quadratic equations. That means to move them around. So you saw in lesson 5.10 that lessons that graphs of all linear functions are transformations of the linear parent function y equals x. This right here is a linear equation, It's a linear equation with nothing on it. It's just a slope of 1 equals 1 and a y-intercept of 0, so it's just a vertical line. It's just a diagonal line, up 1 over 1, up 1 over 1. So we talked about this in class before. The parent function of a quadratic is x squared. So it could be y equals x squared or f of x equals x squared. All right? So if you do all this, the axis of symmetry is x equals 0, the vertex is 0, 0, and the function only has 1, 0, 0. So the graph looks like that. So this is the parent function of a quadratic. That's where you start from whenever you think about changing the quadratic or transforming it. So when we add those other numbers, we put a here, a B with an X here, or a C, that transforms this and is going to move this shape around. So we have all the different other options. Alright, so if we look at these three graphs, the top one is, the red one is our parent function. So we can see, having no numbers here, that's the parent function, the red one. Now the green one is this second function. So the second function, if you put a coefficient of a that is smaller than 1, then the parabola gets wider. Alright? And if you see right here, the -3 of course flips it over. We knew that already. But if you put a coefficient of here in front of the a that's bigger than 1, then it makes the parabola skinnier. So that's the effects. So the a makes it different. If you change the a, it makes the width of the parabola different. Alright? So this is what you need to know. It's really simple. If a, which is the number in front of the x squared, if it's bigger than 1, alright, that's what you want to get over here. If it's a number bigger than 1, then the absolute value, you ignore any negatives. So if it's a number that is bigger than 1, it gets skinnier or narrower. If it's a number that is less than 1, the absolute value of it, so you just ignore any negatives, then the parabola gets wider. So that's what you really need to write down about this. Alright, if you're confused by that, call me over. It's really not that difficult, but it may need a little further explanation. So, which one is going to be narrower? Well, this first, we look at the A's. Alright, the A's for this one is 3. Of course, you ignore the negatives. And the A for this one is, well, that's an error right there. It should just say 0.5, so that's an error right here you're looking at. So I don't know why they changed it to 0.05, it's just 0.5. You don't square it or anything. So that should say 0.5. Now, since this number bigger than 1 makes it narrower, this function right here is going to be narrower. All right? So the narrower function is this one, the top one. All right? This is the exact same problem. Now you could also use, it's just showing you a different way how to do it. You could put both of these in the graphing calculator. You go to the y equals function and also check to see which one's narrower. Alright? So again, which one's narrower? Well, if you just look at the A's, you have 1, 1/2, and 2. So the skinnier one is going to have the bigger number. Pretty simple to do these. So copy some of these examples down. Make sure you're taking good notes so you understand this when you look it back. Of course, that negative, when you're deciding if it's narrower or wider, you just ignore the negative. Or you can use a graphing calculator. If you want to know how to do it, if you're not sure how to put this in a graphing calculator, you can actually put all three functions in at once. You just go to the y equals button. Just call me over. All right. If you want to try this one and pause it and just see if you understand, if you get the right answer, press play when you're ready to go over it. Let's see how you did. And you should know by now, this one's going to be narrower. The second one's going to be wider. All right, so let's go on to a different part here. You can use a graphic calculator. We're not going to keep doing these because they're just repetitive. So we'll skip. All right. So let's look at this number. We've talked about this number before. This is the C. Remember, we're missing the second number. We're missing the B. So the value of C is the y-intercept. So basically, it's going to move it up and down. So the value of C tells you where the vertex of the parabola is. If it's a negative 4, it's going to go down 4, like it did here. If it's a positive 3, it's going to go up 3. So this is pretty simple stuff right here. All right. So this is what you need to think. The vertical translation means going up and down. All right. If C is greater than 0, so if there's this last number usually without an x or an x squared, if it's greater than 0, it goes up. If it's less than 0, it goes down. Make sure you get this down and understand it. If you don't understand it, call me over. When comparing graphs, it's helpful to draw them on the same coordinate plane. So this one, if you want to compare this to the parent function, it's going to be wider because of that, and it's going to be up 3 because it's plus 3. All right, so here's the parent function in red. This one is going to be wider. It's going to be flipped over because it's negative, and the vertex is going to go up 3. All right, and that's exactly what it says here. And they're not asking for specific points. They're just asking you in general what happens. Well, you can tell it's wider. It opens downward, and it also, the vertex is going to be 3 up. All right, the axis symmetry is the same. So what about this one? This one's just going to get, when you compare it to the parent function, it's just going to get narrower. All right? Because that number in front is going to be narrow. All right. Now you could do it in the graphing calculator too. Same vertex because there's no C here, but this is the second equation. Sorry, yeah, this is the second equation. It gets narrower.
It's 1 o'clock.
All right. Yeah, this is another mistake here. They're really messing up because if it's a number smaller than 1, it gets narrower. They did it backwards for some reason. All right, so this one, what's going to happen? The negative means it's going to flip over. There's no A here, it's 1, so that's going to stay the same. It's not going to get narrower or wider, but it is going to get down. The vertex will go down 4. There it is. Flipped over, the vertex moves down 4 because C is negative 4. Alright, if you just want to try this one and tell me what you think happens, we'll see if the answer is actually correct. We can pause it here. Just give it a shot. Alright, if you really paused it now, you should press play and watch the rest. You should press play, you would watch the answer. It's going to be narrower. I wouldn't do all this work, it's too much. The vertex is plus 9, so it's going to go up 9. And then it's going to be narrower. Now this one's correct. They actually did this one correct. So it's up 9 and it's narrower. This one's going to be wider and up 2. Very simple. Alright, so let's move along here. Sorry. The quadratic function, here's a word problem. You should probably copy it down. These are very important on the end of grade test, or EOC for you guys. So it's going to be a wide, sorry, this is going to be a very narrow one. And this will be the height where it starts, as you're going to see in a second. All right, so these two functions are dropped. So if you can see, this goes back, let's go back. This is the general function of anything you drop, because this is the speed it's going to move down towards the ground at in feet per second. So if you drop something, it's going to fall at 16 feet per second. And it's negative because it's falling, it's going down towards the ground, and it's moving at a velocity of 16 feet per second. This would be if there's no wind or air resistance, so no friction or anything else like that. We'll talk about this a little bit more. Let's look at the example they use. So if you drop a softball from 400 feet, you're going to write two different equations, one for 400 feet and one for 324 feet. And so this is a given. Everything you drop will always move down at a velocity of negative 16 feet per second. So you'll put that in front of the t squared. They're using t instead of x. This is where it starts. So you put 400 there. They're going to write another one where you put 324. All right, because that's the starting height. So that would be, if you graphed it, that's where the vertex would be. This one would be up 400. This one would be up 324 feet. All right. Graphing calculator, if you kind of look at it, if you kind of throw a ball, this is what it kind of looks like. So this is going to be the bottom one, where they dropped 324, and this is going to be the top one. And we're going to talk plenty about these problems in class. So how can you tell when it reaches the ground? You want to find the zeros. All right. So you look on the graph, and you find the zeros. This is the same type of problem. If you want to try writing, just write the two equations. They're quadratic equations you would use for this. It shouldn't be too difficult. So pause it here and write the quadratics. That's one drop from 16 feet. That's one drop from 100. Simple. And if you put it in there, that's there. So how much higher is it dropped? 84 feet. How can you tell when it reaches the ground? It reaches the ground when the time is 0. So if we look back at the graph, this right here is the point where it reaches the ground. So you want to find that x value. All right, so that's the lesson for today. It's just kind of some stuff you need to know mixed up all together. It's not really one big lesson. So I'll give you some problems to try on this. If you have any questions about any of the notes you took, go ahead and raise your hand and ask me, and I'll help you out.